Here we have a SAT math problem. Okay, let's go to the question. The graph of the linear function f is shown in the xy plane above. If the graph of g defined by g of x equals to 4 times f of x into 2 positive k, where k is a constant, passes through the point 1 comma negative 4, what is the value of g of 3? Okay, here we have the function g of x, and the graph of this function g of x passes through the point 1 comma negative 4, and we have to find the value of g of 3. Actually, the given function g of x is not complete because it contains an unknown constant k. Okay, if I want to find the value of g of 3, first I have to get the value of this unknown constant k, then only the function will be complete. Okay, for that we can use this information, that is the graph of the function g of x passes through this point 1 comma negative 4. Since it passes through this point, we can plug in this point into the function we have over here. And also, when we have the graph for a function like g of x in an xy plane, this g of x represents y coordinate, so we can consider y for this g of x. And when I plug in this point 1 comma negative 4 into this function, we have to plug in this y coordinate negative 4 for g of x over here, and the x coordinate 1 for x over here. Okay, let me do it. Then we get negative 4 equals to 4 times f of 1 negative 2 positive k. Negative 4 equals to 4 times f of 1 negative 2 is negative 1 positive k. Here we need the value of f of negative 1, and here we have the graph for the function f of x. Actually, this f of negative 1 is the value of y when x equals to negative 1. So in the graph of the function y equals to f of x over here, we have to get the value of y when x equals to negative 1. Okay, here we have the value negative 1 on x-axis. Corresponding to this value negative 1 x on x-axis, the value on the y-axis over here is 3. That is the point over here is negative 1 comma 3. On the graph of y equals to f of x, when x equals to negative 1, y equals to 3. So this 3 is the value of this f of negative 1. Okay, let me plug in 3 for this f of negative 1. Then I'm getting negative 4 equals to 4 times 3 positive k. Negative 4 equals to 4 times 3 is 12 positive k. Let me subtract 12 from both sides of this equation. Then this 12 negative 12 will cancel out. I'm getting negative 16 equals to k. Okay, now what we can do is that we can plug in this negative 16 for k into the function over here, so that the function g of x will be complete. Then we get g of x equals to 4 times f of x negative 2 negative 16. Okay, now what we can do is that we can plug in this 3 for x over here to get the value of g of 3. Okay, let me do it. Then we get g of 3 equals to 4 times f of 3 negative 2 negative 16. Then we get 4 times f of 3 negative 2 is f of 1 negative 16. So here this f of 1 is the value of y when x equals to 1. That is, we have to get the value of y when x equals to 1 in the graph of the function y equals to f of x. Okay, now let me consider the value 1 on the x-axis over here. Corresponding to this value 1 on the x-axis, we have to get the point on the graph of this function. So here we have the point corresponding to this value 1 on the x-axis. Okay, at this point, what is a y coordinate? For that, we have to consider the value on the y-axis over here. That is a negative 1. So the point value over here is 1 comma negative 1. Okay, here when we have x equals to 1, the value of y is a negative 1. So that is the value of this f of 1 is the y coordinate over here. That is negative 1. Okay, now let me plug in negative 1 for f of 1, negative 16. Okay, 4 times negative 1 is negative 4, negative 16. Here when I combine negative 4 and negative 16, I'm getting negative 20. Okay, here I got the value of g of 3. Its value is negative 20. We find negative 20 in answer choice A. The correct answer choice for this question is A.